or your containment unit, which is the domed building. It heats up water, which in turn heats other water, okay, and creates steam. And that steam is what's used to drive a steam turbine like we saw at the beginning of this. H right there indicates the steam turbine, or where H is, which in turn turns a generator. And then the smoke that you see out of the stack, that's not contamination, that's not radiation coming off of it, that's just steam. Okay? That's just steam. All the containment and nuclear rods and fuel are in the containment unit around K. You see the letter K? And that's what is used. The nuclear rods generate the heat, which in turn heats water, which in turn creates steam from other water. So the two waters never touch each other. Okay? How long do you think a nuclear plant can go without being refueled? 5 years. About 5 years. They refuel them about every 5 years. Approximately, yes. It depends on what's going on. This is the generator for the Sharon Harris plant itself. It sits outside, it's so large, and is encased in this housing, the rounded housing. To give you a perspective, that building actually rolls back and forth, depending on where they're working or what's going on. It's 8 stories tall. It's huge. The generator itself is huge. They only have one generator at Sharon Harris. They were supposed to have 4, but cost overruns and other things caused them to lose or not have or be able to install the other 4. This is the containment house at Sharon Harris. It's a dome building, and that's where all the nuclear material that is used to create the hot water, which in turn creates the steam. And this is the control room for that. Not bad. I wouldn't know what to do with half of those knobs. A third of those knobs.
Probably tell you what one did.
I would like to know where the off button is, to be honest, just in case.
They probably have it labeled.
I would hope so.
I doubt it.
All right, and this is a nuclear house, you'll see, or the containment building. The rods are here. It pumps cool water.
Good morning, everyone. I just wanted to give you a quick insight, sneak peek into what we're discussing today here with our 11th grade cohort here at AGORA. We have Mr. Brian Terry of Richmond Community College. He teaches electricity there. He is taking them through a crash course, okay, in power distribution, and that's what our students have been learning for the last 2 sessions here at AGORA, and today he's bringing it all together. So I thought I'd start this live stream off today with giving you a first-hand look into what our students are learning. We're going to be zipping in and out throughout the day to give you more insight, and then even talk with Brian Terry about how this leads to jobs. Okay, this is all about jobs, and this is a field that's wide open, and they can't find enough qualified workers here in the United States. So that's why we have him here today. So stay tuned. We're going to be back. Hope you're enjoying this.
So it's very, very similar. It's just that the prime mover is a little bit different. This particular one will probably produce 240 volts. It should have a 240 volt outlet on it. And it should be able to power, let's see, 5,000 watts most everything in a home. Most everything in a home. Unless, you know, you're like my wife and children that think they can run their hair dryer, curling iron, the bathroom heater, and everything all at one time, and that doesn't work. Because they overstretch the generator, and it'll trip out if you do that. All right, so who said water? Who was my water? We're going to go through your hydroelectric generation. And there's multiple types of hydro generation. We're going to go through two types. The standard type that looks like a dam, that's attached to a dam, and it allows water to flow through it. It turns a water turbine, which in turn turns a generator, and which in turn creates power. All right. This is the outflow right here. Sometimes they're underwater, sometimes they're above water. It depends. I have a little video about the Three Gorges Dam that we may look at in China. It uses so much water, or passes so much water through it, that they take their water channels and point it up in the air. And it shoots out in the air. That way, there's no chance of this outflow of water undermining the dam at the bottom, because you get a lot of turbulence here, and it could undermine the dam. So they use so much, they spray it out in the air, and all that energy is expended into the air. The term they use from this point right here to that point up there at the very top of the dam is called the head. And that's how they determine how powerful or how much electricity a hydroelectric dam can produce. Okay? And how large of a turbine they need to install. You open the control gate, water flows through, turns the turbine, turns the generators on top. The generators send power out to what's called a switch yard, and in the switch yard we step the power up. And I'll explain why we step the power up in just a little bit. Again, this is a powerhouse for all the generators. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9 turbines in this particular one. In the one they built in China across the Yangtze River, I want to say that they have 3 powerhouses with 23 turbines in each one. 23. It's over 1.5 miles long, the dam is.
All right, hey, this is Jeff Epps. I'm now here with the 9th grade cohort. They're working on coding. They're learning to program in Microsoft Small Basic, which teaches them .NET or dotted notation in terms of programming. So I'm going to come over here to our instructor and let you hear about what they're learning, how they're learning it, and why they're learning it. Mr. Drew.
Yes, sir.
You're now live on the internet.
I love being
please
live.
tell people who you are and what these kids are doing today?
Oh, well, I'm Drew Blazo, and I'm teaching these 9th graders how to do graphics programming, but we're secretly teaching them like the XY axis and right angles and equilateral triangles, and we're teaching them all that as we teach them this. So right now they're just drawing me pictures. They're trying to draw a perfect square, perfect equilateral triangles, and a stick figure for fun times. All using the coordinate system in the graphics window. So they're still learning about the x-axis and all that good stuff.
And what do you do by trade?
Oh, by trade, I teach every science you could imagine. I teach AP Physics, AP Environmental Science, 9th grader science, honors physics, and occasionally astronomy. So I do that for fun times. I'm the biggest dork you could ever hope to meet.
and folks, hey, he's one of the coolest ones you'll ever meet too. Thanks, Drew.
Anytime.
Appreciate it. All right, let's scroll around here and let's find out, see who we can talk to here. I don't know, this group over here looks engaged. What are you guys up to today?
I'm trying to get an equilateral triangle.
An equilateral triangle. You're trying to do that with code?
Yes, sir.
So, do you mind if we show everybody on the internet what your code looks like right now? Does it work?
It keeps making isosceles, so I keep making small changes to try to get closer and closer to equilateral.
All right, we're going to zoom in on your code. So tell us what all this means. For those people that have no idea what that means, what is go through it line by line here. Line
Okay.
1, line 2.
Well, this basically just makes the graphics window pop up. This makes the turtle appear, which is the little guy that moves around with a pin. This tells the turtle to move, and that's the bottom line of the square. And then this made the graphics window a little bit bigger, so I had more space to work. These two lines 4 and 5 here. And then this is telling the turtle to turn, this is telling him to move. So this made him turn 90 degrees. And so this through here is him making a square. And then this is lifting up the pin so when he moves it doesn't make an ugly line. And then I moved him, and then I turned him 180 degrees and moved him by 90 pixels. And then put the pin back down, and this is where I start drawing the triangle. So if I run it, then he creates a square right there.
So I can do it. The other activity 1, turtle graphics.
Whoa, okay.
I'll unfreeze this so you can see.
Excellent. Very good, young man. Thank you. Thank you for sharing. Well, as you can see here, this young man not only is learning to code, but he also learns to decode because he was able to take what he wrote and explain it to us in detail based on each line of code. So the ability to code and decode is a huge skill in the workplace that employers really look for. So folks, hey, let me get a shot at him one more time. This is the future workforce. This is a future DOD engineer going to keep us safe here in this country. Great job, young man. All right, this is Jeff Epps. I'll be back in a little bit. I'm out. All right, we are about to go live now in with cohort number 2, and they are learning they're learning 3D modeling, okay? So let's tune in.
So this is review. It should be going really fast. Look around. If we've lost somebody, can you try to help them for me? Get them up where we need to be. Yes, sir.
Hey, good to see you. Welcome back. So what you got going here?
So we're making the spaceship.
You are making a spaceship. That's not a spaceship, that's a block. How are you going to make a spaceship from a block?
We're gonna keep extruding and beveling it.
You're extruding and beveling it. Okay, what is extruding and beveling?
Extruding
Numbers on that
is
USB.
making a face more
And
like
outer
three-dimensional, and beveling
No,
is
the
once you do that, you
on the
extrude,
USB.
and then you change the side of one of the faces, the size.
Very cool. All right, folks, look, it's a little dark in here because the kids are actually learning by watching the video, so I didn't want you to think we keep our children here in the dark at AGORA. That's not the case. They just need to be able to see the projector, okay? All right. So, what program is this you're using?
3ds Max.
3ds Max. So, the ability to visualize a concept. Very good. Glad to see you.
All right, so we're almost at the end of this. We're about halfway done. Everybody ready?
Because I don't see my faces to edge mode. And then I'm going to come down here and hit zoom extends all so I can see. And we will stop here at 1.
Okay, if you don't see those white lines, you need to do F2 or F4, and it'll show the edge of faces mode.
Okay, let's start with part 2.
All right, so
Nope.
the ability to visualize is a skill that employers covet, and these students are getting it. We're going to come back a little bit later, hopefully when the light's on and you can see a little bit and interview some students. But once again, this is part of what happens in AGORA on Saturday. We expose students to emerging technologies and give them access to tools that give them the ability to visualize any concept. So when you can go from concept to digital to physical or concept to digital, they have a word for that. It's called engineering. Jeff Epps, I'll be back in a bit.